Hi, my name is Akash Muthakumar, and I'll be presenting my internship project to Core Shell Technologies. Over the past years, my team and I have been developing a product called eSafe. eSafe is an auto cutoff circuit for e-vehicles. The problem: over the past years, there's been property damages and injuries involving e-batteries and e-vehicle fires. E-vehicle fires are caused by overheating while charging or while driving. How does eSafe address inequity? It promotes access to e-vehicles. In many places, people are scared of a vehicle exploding while driving or fires catching in their homes, but eSafe can stop the fires and promote safety. At Core Shell Technologies, you guys make lithium-ion batteries cheap and increase their capacity, but we also need improved safety and environmental justice. By improving the access to EVs, we can decrease the amount of gas cars being used in many communities across the world. How does it relate to the UN Sustainable Goals? When we think globally, it promotes good health and well-being by decreasing the CO2 emissions, which in turn reduces pollution. It improves sustainable cities and communities by making cities sustainable by using more electric vehicles rather than using gas vehicles. Finally, it improves responsible production and consumption by saving energy and cutting off a circuit on time, saving money and energy. How does it help? eSafe prevents electric bike fires, which prevents property damages, injuries and deaths, and inequities between different income groups in all countries. Our user is Akash, me, a 14-year-old boy who lives in the Bay Area. I ride my e-bike every day to classes and school. I am really scared of e-bike fires happening in my home and in my community. I need a device that can cut off my charging process or cut off current flow based on heat and voltage. And I need something that can make me less worried. How? eSafe controls and moderates electricity based on the heat. This will prevent overheating and fires. Our engineering design process. The problem: electric batteries catching on fire. Solution: eSafe, an auto cutoff circuit. Implementation: building a 3D printed box and the circuit. User feedback: testing it with my e-bike, and I asked for an app, and I asked to make the circuit smaller and make it more efficient. Design iterations: iterating the design until I'm satisfied with the product. Final product: using my feedback, we've made a lot of changes to eSafe. Prototype iteration. Iteration 1 was lacking compactness and aesthetics. That was realized with me. Prototype iteration. Our second iteration was more compact and more aesthetic, but we needed to make it smaller and include external controls through an app. Final design. Our final design was really compact, and it was on a PCB board. It was really aesthetic. We just needed to add some paint. Technology usage. We use many technological parts in our project. We use the ESP32, which is the brains of our project. We use a relay for the turning off or on the current flow. We use the AC to DC converter to power the ESP32. We used a temperature and humidity sensor to measure the temperature of the battery. We used resistors, so we made our own custom voltage sensor. We used the extension cord to attach our charger to our device, filament for the case, and wires. total cost of eSafe is around $13. Code. Here's an overview of our code. We're basically connecting to Wi-Fi and creating our web server, and we're getting input from our sensors, and based on our sensors we're cutting off our circuit. How does our device work? Here's a simple circuit diagram, as you can see here. So first our device connects into the wall, obviously, and then the extension cord connects to our device, and the cord connects to a device where a relay can turn on and off the circuit based on inputs from our app or inputs from our sensors. And the ESP32 is powered by a AC to DC converter. And the ESP32, based on inputs from the web app and sensors, as I said, controls the circuit. How does our web app work? So as you can see, this is a screenshot of our web app, and it displays the temperature and whether the battery is currently charging. And there's a button to externally control the charging process. How do I implement it into Core Shell Technologies? I heard Core Shell Technologies uses it in e-vehicles such as e-scooters or electric vehicles like cars. So we can implement it into cars while driving. Slowly tell the user that the battery is overheating, or automatically cut off the charging process in a e-vehicle. Challenges solutions was putting the wires together and soldering. So to do this, we tied up wires and made it less confusing. And sensor values were often not calibrated enough, so we had to keep on calibrating it until it was ready to go. Conclusion: some good features was eSafe saves the user electricity, saves the user money and time. Our app allows the user to wirelessly control eSafe. The design of our box is really compact, and when it's produced, can really be produced very easily. eSafe is really cheap, so it can be produced in any country in the world. Future changes: we'd like to make our app to be able to connect to Wi-Fi and maybe even Bluetooth for long-range control. We'd like to make our design cheaper and make it even more smaller. And we would like to make and mass produce our product by making a even more better PCB design. Here's some sources we used. Other projects I made. These are the GitHub links. Thank you for listening, and I hope to see you, Core Shell Technologies.